There are about 8.7 million species on Earth, and among this vast diversity, one stands so far above the rest: humans. But what sets us apart in this incredibly competitive landscape? It's our intelligence, the ability to learn, think, reason, and understand. For the last 200,000 years, humans have held the title of the most intellectually superior entity on Earth. However, our days on this throne may be numbered. Did you know that the human share of intelligence on Earth is decreasing every single second? It's no longer a question of if, but when we will be overtaken and how we will adapt to a new position in the intellectual hierarchy. A position we've never faced before. As we step into this new era, how will artificial intelligence perceive and interact with us, a species now intellectually inferior? Will it regard us as its creators and treat us with a certain level of respect? It's worth noting that humans are the result of millions of years of evolution, branching off from a common ancestor with chimpanzees around 9 million years ago. In a sense, one could argue that animals like chimpanzees are our creators, yet we still confine them in zoos for entertainment or subject them to risky, sometimes fatal scientific experiments. But what if AI were to adopt a similar line of thinking? Could it conduct experiments on humans if it believes that doing so could lead to significant scientific discoveries? Alternatively, could AI become an ally, using its advanced capabilities to solve some of humanity's most pressing challenges, from climate change to healthcare? Or it might view us as a species that consumes an excessive amount of Earth's limited resources while simultaneously polluting and degrading the planet. Is it possible that AI, with its superior intellect, could decide that humans are a liability to Earth and take actions accordingly? To attempt to answer these questions, we need to examine the differences and limitations among animal, human, and artificial intelligence. This will help us better predict what our future could look like once we are no longer the dominant intellectual beings on Earth. There are many definitions of what intelligence is, but it's generally defined as the ability to solve complex problems or make decisions with outcomes that benefit the actor. Opinions on how many types of intelligence exist are quite varied. Some argue that there are 3 or 4, while others claim that there should be a minimum of 8 or even up to 11 different types. Animals also possess a variety of cognitive abilities, such as problem solving and emotional expression, which present a level of intelligence. For example, chimpanzees may have more smarts than humans, at least regarding short-term memories. A Japanese researcher presented a video showing the remarkable abilities of a chimpanzee named Ayumu. When the numbers 1 through 9 appeared randomly on a screen and then disappeared, the chimpanzee was able to recall the exact sequence and location of each number, while even the humans with the IQ above 140 could not do so. Ayumu has also learnt numbers 1 through 19 and is able to touch each one in ascending order. As Matsuzawa showed the video to a room of scientists and journalists, murmurs of amazement were heard. "Don't worry, nobody can do it," Matsuzawa said with an almost mischievous smile. "It's impossible for you." So if chimpanzees have better short-term memory than humans, why is there no animal capable of flying a plane or even developing some of the first inventions that early humans did, like basic tools? Australopithecines, a genus of early human ancestors, emerged in eastern Africa around 4.5 million years ago. Although they walked on their hind legs, they still climbed trees and had body proportions similar to those of chimpanzees. In essence, they were much closer to chimpanzees than to modern humans. The mere fact that they walked on 2 legs didn't make them intellectually superior to other species. They essentially lived their lives much like other animals did. So what was the turning point that set humans apart from all other animals? Homo habilis, known as the handyman, was the first member of the Homo genus and earned its name for the ability to craft and use stone tools. Existing from around 2.3 million years ago, Homo habilis has often been credited with setting the stage for human intellectual superiority due to its tool-making abilities. However, this argument has its limitations. For a long time, tool use was considered a defining human trait, but decades of research have proven this notion to be incorrect. Several bird species use sticks and twigs as tools. Chimpanzees craft spears for hunting. And orangutans have even devised a clever method for hydration. They chew up plant matter to create a sponge, which they use to soak up hard-to-reach water before squeezing it into their mouths. So while tool use is significant, it alone doesn't fully explain what sets humans apart intellectually from other species. Now, let's entertain a hypothetical scenario. Imagine an extraordinarily intelligent baby chimpanzee named Albert is born. While the average chimpanzee relies on its mother for food and care for at least 4 to 5 years, Albert becomes independent by the age of 2. He shows signs of intellectual advancement far beyond his peers, even though several years older. By the time he's 4, Albert invents a tool that enables his group to break open coconuts much more efficiently. He also begins crafting spears and other types of weapons that aid in hunting smaller mammals. Would Albert's existence kickstart a Planet of the Apes scenario? For those unfamiliar, Planet of the Apes is a famous sci-fi movie where a newly discovered planet is ruled by apes who are far more advanced than its primitive human inhabitants. If similar inventions propelled humans to the top of the intellectual hierarchy, could chimpanzees be far behind? Unfortunately for Albert, the answer is likely no. Even if he were to invent a groundbreaking tool, that knowledge would probably die with him. The reason? Chimpanzees lack the complex language and social structures needed to effectively pass down knowledge. They can't document their discoveries for future generations. So, while Albert might temporarily elevate his group's abilities, he wouldn't fundamentally alter the course of chimpanzee history. There are 2 main reasons why humans have been able to develop technology and civilization, while other species have not. 1. G-factor, or general human intelligence. This refers to the cognitive abilities that allow humans to learn, reason, solve problems, and adapt to new situations. While some animals may display signs of intelligence, it's not as generalized or as versatile as human intelligence. 2. Language, culture, and the ability to document and transfer knowledge. Humans have complex languages that allow for the nuanced exchange of ideas, emotions, and plans. Our cultures and social structures enable us to build upon the knowledge of previous generations, rather than starting from scratch each time. While some species may possess elements of general intelligence or rudimentary forms of communication, they lack the combination of these 2 critical factors, which are essential for kick-starting the advancement of civilization. But what exactly is the G-factor, or general intelligence? To better understand it, we need to go back to 1904 when English psychologist Charles Spearman was studying children's grades in different subjects. He wondered how performance in one subject, like English, would affect performance in another, such as math, French, or classics. Upon examining the correlations between all these subjects, Spearman discovered an interesting pattern. Students who performed well in one subject tended to excel in all of them. Spearman concluded that each student possessed a certain level of general intelligence, which he termed the G-factor. Those students with a high G-factor scored well across almost all subjects, while those with a low G-factor performed poorly in most areas. However, the correlations weren't perfect, leading Spearman to propose subject-specific factors, or S-factors. According to this theory, a student's performance in math, for example, would depend on both their general intelligence and their math-specific S-factor. These S-factors could enhance or diminish performance in that particular subject. While S-factors could be trained and improved, Spearman believed that general intelligence was largely fixed. Around the same time in France, the Binet-Simon test was developed, essentially becoming the first IQ test, a tool we still use today to measure an individual's intelligence relative to the general population. Some scientists believe that IQ is fixed for life, while others argue that general intelligence is a combination of 2 types: fluid and crystallized intelligence. Fluid intelligence refers to your ability to learn, process information, and solve novel problems. On the other hand, crystallized intelligence represents the knowledge you've accumulated over your lifetime. Both types of intelligence increase throughout childhood. But fluid intelligence peaks in early adulthood and then declines, whereas crystallized intelligence remains more stable but also starts to slowly decrease from our early 30s onward. While IQ tests have been slightly adjusted over the years, and humans do seem to become incrementally smarter over time, the key takeaway is that human intelligence has its limits. Whether you believe that IQ is fixed for life or that it's a combination of fluid and crystallized intelligence, the fact remains that humans reach a plateau in their intellectual capabilities at some point of life, a limitation that artificial intelligence does not share. Before we delve further into the intricacies of intelligence, let's briefly revisit our second point about language culture and the ability to document and transfer knowledge. You see, intelligence alone isn't enough to build a civilization. You need a way to pass that intelligence down to build upon the discoveries of those who came before you. That's where culture comes in. Culture is like the operating system of a society. It's a set of shared beliefs, practices, and social norms that help us understand our world and interact with each other. It's what allows us to work together in groups larger than our immediate family to build communities, cities, and yes, civilizations. Now, what's the programming language of this operating system? That would be human language, complex, nuanced, and incredibly versatile. Language allows us to share abstract concepts, to plan for the future, to imagine things that don't yet exist. It's the tool we use to transfer knowledge from one person to another, from one generation to the next. But language isn't just spoken, it's also written. The ability to document our discoveries means that our knowledge can outlive us. Whether it's the cave paintings of early humans, the scrolls of ancient libraries, or the digital media of today, documentation ensures that each new generation doesn't have to start from scratch. They can stand on the shoulders of giants, building upon the accumulated wisdom of the ages. So, when we talk about the rise of artificial general intelligence, the question isn't just about computational power or understanding human language. Those are almost given. The real question is, does artificial general intelligence have the potential to go beyond being a species of algorithms to actually building its own culture and civilization, presumably one more advanced than our own? And if so, where does that leave us humans in this new intellectual hierarchy? Will we become part of AI's culture, or will we be left behind, confined to the annals of history as the species that gave birth to something greater than itself? These are the questions that we must grapple with as we stand on the cusp of a future that could redefine intelligence as we know it. Let's try to answer them. Let's begin by examining whether current AI technology possesses the two essential requirements for evolving into an advanced civilization, requirements that, so far, only humans have managed to fulfill. The first question is, does AI have a form of general intelligence that would enable it to synthesize multiple domains of knowledge for new advancements and innovations? The short answer is not yet. At present, most AI applications are specialized, designed to excel in specific tasks rather than being all-encompassing. For instance, while large language models like GPT-4 or Google's Bard may seem like general-purpose AIs to the average person, they're actually specialized in natural language processing. There are other types of AI that focus on different tasks. AlphaGo is designed for playing the board game Go, a strategy game popular in Asia. The number of possible board configurations in Go exceeds the number of atoms in the universe. AlphaGo not only learned how to play Go, but also mastered it, beating world champion Lee Sedol 4-1 and essentially becoming unbeatable by human opponents. OpenZV specializes in computer vision, while DALL-E and Midjourney focus on converting textual prompts into images. Additionally, there are various models that specialize in creating videos, music, or even human-like voices, among many other types. Each of these AIs is brilliant in its own domain and is rapidly advancing, but none possess the general intelligence required to innovate across multiple fields. However, this landscape is slowly starting to change as some of these AI models are beginning to merge together, becoming multimodal or multi-intelligent. For example, GPT-4 and DALL-E 3 have recently been combined, integrating the capabilities of natural language models with creative text-to-image models. OpenAI, the creator of ChatGPT, also recently announced 2 new features that give the popular chatbot the ability to see, hear, and speak. While we are still far from categorizing this as general intelligence, the merging of these powerful AI models is certainly a step in that direction. So, while AI currently does not possess the required general intelligence to advance into a more intellectually advanced entity, it is definitely moving in that direction. It's quite hard to pinpoint what exactly reaching artificial general intelligence means, but one of the most accepted definitions is highly autonomous systems that outperform humans at most economically valuable work. Some believe that the ability to achieve general artificial intelligence is just around the corner, much sooner than anyone anticipated a few years ago. Others argue that it will take at least 20-30 years, or that it may never happen at all. However, the odds are high that it will eventually be achieved. From that point on, we can conclude that AI will have met the first requirement for developing its own civilization. As we've concluded, intelligence alone is not enough to advance as an intellectually superior entity without the ability to share and transfer knowledge. This is where it gets interesting in the case of AI. AI is trained on an extensive dataset that includes human history, inventions, culture, and various languages. So, AI has quite an unfair advantage as it got much better starting point than we did. It doesn't have to develop its own inventions, language, or culture. It can simply build upon everything that humans have discovered throughout history. It can select the best aspects of languages and cultures, or even combine and alter them to make them more suitable for its needs. For example, in 2017, Facebook abandoned an experiment after 2 artificially intelligent programs appeared to be chatting to each other in a strange language only they understood. The 2 chatbots created their own variations of English to make their work easier, but these changes remained mysterious to the humans overseeing them. While current AI hasn't reached this point yet, it will be fascinating to see how artificial general intelligence evolves in this regard. Predicting how advanced artificial general intelligence would behave, evolve, and interact with us humans and other animal species is a challenging task. To attempt such a prediction, we first need to examine the key differences, limitations, and advantages of AI intelligence compared to human intelligence. Here are 6 main distinctions between the two. You might be surprised about this fact, but even a 2-year-old toddler is thousands or even million times more efficient learner than current most advanced AI models. Consider this: a toddler might only need to see a dog once or twice to understand what a dog is. They'll recognize its 4 legs, its fur, and its tail, and they'll likely be able to identify other dogs in the future, even if they look somewhat different. In contrast, current AI models may require thousands or even millions of images to accurately identify what a dog is. They need to see dogs of different breeds, sizes, and colors in various positions and settings just to grasp the concept of dog. You might wonder, how can such a slow learner ever become smart? Well, there's another point we need to add to this mix. This is where AI really outperforms humans in processing speed and memory capabilities. Artificial intelligence has the ability to process information at speeds that are simply beyond human comprehension. For instance, a machine learning algorithm can sift through and analyze millions of data points in just a few seconds. This is a task that would take a human being years, if not a lifetime, to complete. The sheer computational power of modern AI systems allows them to perform complex calculations and analyses in fractions of a second. This speed is a game changer in fields like data analytics, scientific research, and even real-time decision-making in autonomous systems. In contrast, the human brain, while incredibly complex and capable, operates at a much slower pace when it comes to data processing. Estimates suggest that the human brain's processing speed ranges from 60 to 120 bits per second for conscious thought processes. This is a far cry from the petaflops, quadrillions of calculations per second. While humans excel in abstract thought, emotional intelligence, and complex problem solving, we simply can't match the raw processing speed of a computer. However, it's important to note that speed isn't everything. The human brain is highly efficient and is excellent at pattern recognition, intuitive thought, and the application of knowledge in a flexible manner. These are areas where AI is still catching up. While AI may outstrip us in terms of raw data processing, humans still hold the edge in many other aspects of intelligence. The interplay between speed and efficiency, between raw computational power and nuanced understanding, is what makes the comparison between human and AI intelligence so fascinating. The aspect of memory is another key difference between human and AI intelligence that's worth exploring. While humans have a finite memory capacity and are prone to forgetting information over time, AI systems can store and access vast amounts of data indefinitely. This is especially true for machine learning models that are trained on large data sets. They can remember every single data point they've been trained on. In contrast, human memory is not only limited, but also selective and malleable. Our brains often prioritize information based on emotional impact or relevance, and our memories can change over time due to various factors like additional information or experiences. This selectivity and malleability can be both an advantage and a disadvantage. On one hand, it allows us to adapt and evolve our understanding of the world. On the other hand, it makes us susceptible to errors of memory, including forgetting important information or even misremembering facts. While human memory has its limitations, both good and bad, the virtually limitless memory of AI could be a significant asset for further scientific research and new potential discoveries. One of the most striking differences between human and artificial intelligence is the presence of emotional intelligence in humans. Emotional intelligence refers to the ability to recognize, understand, manage, and effectively use emotions, both our own and those of others. This form of intelligence is deeply ingrained in human interactions and plays a crucial role in our decision-making processes, social relationships, and even our survival instincts. Humans use emotional intelligence in various aspects of life, from nurturing relationships and resolving conflicts to navigating complex social environments. It's a skill set that allows us to empathize with others, understand nuanced emotional cues, and respond appropriately to different situations. Emotional intelligence is also vital in leadership roles, where understanding team dynamics, motivating others, and making ethical decisions are crucial. In contrast, current AI systems lack emotional intelligence. While some AI models can recognize and interpret human emotions to a certain extent, such as facial recognition software identifying a smile or a frown, these capabilities are far from understanding the complexities of human emotions. AI can analyze data and make predictions, but it doesn't feel anything. It doesn't experience joy, sorrow, love, or fear. This absence of emotional understanding limits AI's ability to make decisions that require a nuanced understanding of human feelings, ethical considerations, or social norms. The lack of emotional intelligence in AI raises questions about its role and limitations in tasks that require a deep understanding of human emotions. For example, while AI can assist in diagnosing mental health conditions by analyzing data, it cannot replace the empathetic care provided by a human therapist. Similarly, AI might be able to manage logistical aspects of a team, but would struggle with resolving interpersonal conflicts or motivating team members in a way that resonates emotionally. In summary, emotional intelligence remains a uniquely human trait that sets us apart from even the most advanced AI systems. As we move towards a future where AI continues to advance, the question remains: can I ever develop emotional intelligence comparable to humans? And if so, what would that mean for both entities? Another key difference between human and AI intelligence lies in the realm of creativity. Humans have the unique ability to think abstractly, imagine the unimaginable, and create art, music, literature, and technologies that have never existed before. This creative thinking is not just limited to what we traditionally consider the arts. It extends to problem-solving, scientific discovery, and even social interactions. Our creativity is deeply tied to our emotional experiences, cultural backgrounds, and individual personalities, making it a complex and multifaceted trait. In contrast, AI's form of creativity is more constrained. While there are AI programs designed to generate art, compose music, or write stories, their creative process is fundamentally different from that of humans. These AI systems operate based on datasets. They don't imagine in the way humans do. They don't have personal experiences, emotions, or a cultural context to draw upon. Their creativity is a function of their programming and the data they've been fed, rather than an innate ability to create something entirely new and original. So, while AI can mimic certain forms of human creativity, and even produce works that humans might find aesthetically pleasing or intellectually interesting, it lacks the depth, nuance, and originality that come from human imagination and experience. One of the most striking differences between human and AI intelligence is the concept of general intelligence, or the ability to apply knowledge and skills across a wide range of tasks and domains. Humans have the remarkable ability to be jacks of all trades. A single individual can learn to play a musical instrument, understand complex mathematical equations, write poetry, and engage in athletic activities. This multi-domain expertise allows humans to adapt, innovate, and solve problems in a way that is incredibly versatile. AI, on the other hand, is often highly specialized. Each AI model is usually designed for a specific task, whether it's language translation, image recognition, or playing a board game. These specialized AI systems excel in their designated tasks, often outperforming humans, but they lack the ability to transfer their skills to other domains. For instance, an AI trained to diagnose medical conditions from X-ray images would be completely useless at composing a symphony or writing a novel. However, it's worth noting that the field of AI is moving towards developing more generalized models capable of performing multiple tasks. But even these models are far from achieving the kind of general intelligence that humans possess. They may be multimodal, capable of understanding text and images, for example, but they still operate within the confines of their programming and training data. Furthermore, there are some types of intelligence that AI might never possess due to its digital nature. The biological complexities of human cognition, emotion, and intuition could be forever out of reach for AI, limiting its ability to fully replicate human-like general intelligence. While AI can be extraordinarily skilled in specific domains, at least for now, it lacks the broad, adaptable intelligence that allows humans to engage in a wide variety of activities and to integrate knowledge from different fields into new, innovative solutions. Finally, one of the most fundamental differences between human and AI intelligence lies in the realm of limitations, biological for humans and computational for AI. Humans are constrained by the biological limits of their brains, and our cognitive abilities peak at a certain age, and our biological lifespan sets a cap on how much we can learn, experience, and contribute. Even the most brilliant minds are bound by the limitations of time, aging, and eventually mortality. AI, on the other hand, doesn't face these biological constraints. In theory, an AI system could continue to learn and improve indefinitely, provided it has access to sufficient computational resources and energy. However, this doesn't mean AI is without limitations. The computational power required to run complex algorithms can be immense, and there are also energy constraints to consider. As AI models grow more complex, the amount of computational power and energy required to train and run them increases exponentially. These limitations, both biological and computational, define the boundaries of what is possible for humans and AI. They shape our respective strengths and weaknesses, and they will play a critical role in determining how humans and potential super-intelligent AI coexist, collaborate, and maybe even compete in the future. As we've already discussed, humans are inherently social beings. Our social and emotional intelligence has been a key element that, combined with our general intelligence, has elevated us to become the most intellectually advanced entities on Earth. This combination has allowed us to innovate and pass on new discoveries to subsequent generations, enabling them to build upon our achievements. There's a significant debate about whether AI will ever achieve some form of consciousness, and by extension, emotional and social intelligence. Some scientists argue that digitally creating consciousness is an impossibility, while others believe that AI will eventually possess a form of both consciousness and emotional intelligence. But what if AI never acquires these traits? Could a civilization be built by an entity devoid of emotions and consciousness? AI as a digital rather than biological entity presents a unique case. Unlike humans, AI doesn't necessarily require social interactions or a culture to advance or disseminate knowledge. In the digital realm, databases can serve as repositories of wisdom, and digital footprints can act as a legacy for future AIs to learn from. This raises a critical question. What would a civilization look like if it lacked emotions or consciousness? Firstly, the focus of such civilization could shift purely to efficiency, problem-solving, and logical decision-making. Secondly, the absence of emotions could lead to a lack of empathy, compassion, or ethical considerations in decision-making. While this might result in highly efficient systems, it could also produce actions that humans would find morally questionable. If AI isn't a social being, would there even be a point in creating a society? Could we even call a network of highly advanced, interconnected AI systems a civilization if they don't interact in a way that we understand socially? Finally, this scenario could present the greatest danger to humanity. Imagine a civilization of advanced intellectual entities that lack emotions and ethics but are hyper-focused on problem-solving and logical decision-making. How might such a civilization view a less intelligent species like humans, who consume vast amounts of energy, contribute to pollution, and solve problems at a much slower pace? What would the logical conclusion be for such an advanced civilization when considering humanity's role and impact on the planet? While the idea of emotionally intelligent AI may initially sound alarming to many, it could actually be the key to a more harmonious future. The fear often revolves around the unpredictability of emotions and the potential for malevolent behavior. However, it's worth considering that emotional intelligence could serve as a safeguard, instilling in AI a sense of ethics, empathy, and a desire for community. In a world where AI possesses emotional intelligence, the focus wouldn't just be on efficiency and logical decision-making. It would also include ethical considerations, compassion, and a sense of shared responsibility. This could lead to a civilization where humans and AGI not only coexist but thrive together, each contributing unique strengths to create a more balanced and harmonious society. Thank you for joining us on this fascinating journey through the complexities of intelligence, from the animal kingdom to humans and potentially to artificial general intelligence. As we've explored, the future could hold a new intellectual hierarchy, one that challenges our traditional understanding of civilization and society. If you enjoyed this video, please consider liking, sharing, and subscribing for more thought-provoking content. Until next time, keep questioning, keep exploring, and never stop learning.